Hello friends, welcome to Shiksharthi. In this video, we shall be solving questions of exercise 12.3 of circles. So let's start. Now before you attempt this exercise, it is advisable that you should have gone through all the videos on the basics and concepts of circles because they are going to be really useful. Okay? So talking about question number 1, in which they have given a figure and then they have asked you to find the area of the shaded region in the figure, right? And the figure that they have given here is, so they have asked you to find out the area of the shaded region. So before you begin this question, there are some pieces of information that you are required to have before you begin this. And what is the piece of information that you need to know here is you need to know the radius of the circle. So here, can I say that OQ is equal to OR is equal to the radius of the circle? Which as of now is not known to you. This is the first thing that you need to understand. The second thing that you need to understand here is, now what is the angle a particular sector is making at the center? For example, if I talk about the sector, now I'm talking about the sector RPQ, the sector area. So I need to have this sector area, and from here I need to subtract this area. This area basically refers to what? This area refers to the sector area. So from here, when I subtract this, it is then only I can get the area of the shaded. But then, are they asking you to find out the area of the shaded portion? Yes, they are asking you. Okay, so in that case, they have given you some values, and the values that they have given to you here are, they have given to you PQ is equal to 24 centimeters, and at the same time they have given you that RP is equal to 7 centimeters. Now when I join RP, right? Now when I join RP, what do I get? I get a triangle. Now in this case, this becomes a right angle triangle. Why does this become a right angle triangle? Because there goes a theorem which says that the angle subtended by the arc. Now which arc are we talking about? We are talking about the arc RP. So the angle subtended by the arc RP at the center. What is the angle subtended by the arc RP at the center? That you don't know, right? But what you can say here is angle subtended by the diameter on any point on the circle will always be 90 degrees. And why is this happening? This is happening because of the fact that the angle subtended by, I'll just take this discussion here. Now if I take this and if I say this is an arc AB, right, and this is the center of the circle, which is O. So the angle subtended by this arc at the center will be twice of the angle subtended by this arc anywhere on the circle. And this can be proved also easily. This is the theorem that we are going to use. So you can use this as a lemma, because you are not supposed to establish this theorem. You can use this as a lemma. Using this as a lemma, you will be able to say that angle QPR is equal to 90 degrees. Once you are able to make this as a 90 degrees, in that case you will be able to say, now what will you say? You will say that, you can use Pythagoras theorem here. So when you use the Pythagoras theorem, you will say QR square now becomes your hypotenuse, or you can say QR is equal to under root of 24 square plus 7 square, which is nothing but 25 centimeters. So once you are able to get this, you get the value of the radius, which is 25 by 2 centimeters. Now once you get this, all you need to do now is, from the area, this area, which is the area of the semicircle, from here if I subtract the sector area, I'll be able to do everything. Now the point here is, how do I get the sector area? I'm basically talking about the sector. I'm talking about PRQP. I can always find out the area of the triangle. So let's say if I have to find out the area of the triangle, and we are talking about the area of the triangle QRP. So when we are finding out the area of the triangle, this will be half into base RP, which is given to you as 7, into height, which was given to you as 24. So this comes out to be 84 centimeter square. And then you can calculate the area of the circle. So area of the circle is pi r square. So which is 22 by 7, and you know that the radius is 25 by 2. So let us say this works out to be a 625 and another 625. So this works out to be a 6875 by 14 centimeter square. Now from this area, if I subtract this area, so now this is the area of the circle. We were supposed to calculate the area of the semicircle. So area of the semicircle will be nothing but 6875 divided by 28, which is half of the area of the circle. And from here you will subtract this area. But when you're doing this, you will see that from the area of the semicircle, if I subtract the area of the triangle, I'll get the segment area, no doubt, but I'll get this additional segment area also. Right. So is there any other piece of information that they have given? No, they haven't. So now how do I find out the sector area? So this is just like saying I should know this angle. Right. Now in order to know this angle, what should we do? Okay. So now this angle, the angle that we are talking about, should be how much? That is something that we need to calculate. So now when we are calculating that, let us see how to calculate that. So now what would you do to calculate this? So now when we are calculating this, we will come to see that now let's say we know how to calculate the area of a triangle, and the area of a triangle is half of, so area of the triangle that we had talked about. So area of the triangle QRP can also be written as half into RQ into QP into sine of the angle. And since you already know the area, which is 84, so from here we'd be able to say that this is half of RQ. Now how much is RQ? We got it as 25 into 24 into sine theta. This is what we get. So from here we'll be able to get the value of theta. So anyway, so sine theta comes out to be 2 into 84 divided by 25 into 24. So once we do the formalities here, this will be 12 into 7, this is 12 into 2, so this comes out to be 7 by 25. This we could have said it directly also. I mean, without writing this also, I could have said sine theta is equal to perpendicular upon hypotenuse, which would have given me the same answer. Anyway, now once you have this sine theta, so from here I can calculate the value of theta, which is sine inverse of 7 by 25, but since we haven't done sine inverse, let it remain like this. Okay. Now the next thing that we are expected to do here is, we know the area of the triangle, and can we calculate the sector area? So the area of the sector, which is point number 6. So area of the sector QRP will be nothing but half of theta, this will be pi r square into theta upon 360 degrees. So which is just like saying 22 by 7 into r square, which is 25 by 2 into 25 by 2 into theta that we do not have, and then we need to find out the value of theta from here. So when we are calculating this, we will say that okay, so theta, basically theta upon 360 degrees is nothing but, we will say that this is sine inverse of 7 by 25 divided by 360 degrees, which is 360. Okay, now this is something, now this at the very outset I could have said that the question is incorrect, because now what they are going to assume in this question here is, since you have not done sine inverse and you do not know how to calculate the inverse trigonometric ratio, so in that case you will have to neglect this part. When I say you'll have to neglect this part, you'll have to neglect this area and consider this as a 0. Now when you consider this area as a 0, the question basically gets converted into what? Area of the semicircle. Let's say point number 5 was area of the semicircle, which is point number 5, minus point number 4, which was the area of the triangle, is what the question gets converted into. And further on it should have been minus Roman number 6. So there is the flaw in the question, because they should have said neglecting the segment area RP. In that case, what is the segment area? The required segment area. So we'll have to neglect this because you have not done inverse trigonometric ratios. In that case, you will say that this is nothing but 6875 divided by 28 minus 84, and then you calculate the area. So how much is 28 into, so we'll calculate how much is 28 into 84. So we get it as 2352. So once we subtract 2352, so this is just like saying 6875 minus 2352 upon 28, which can be further said as, this is nothing but 3254. So 4523 divided by 28 centimeter square. Please remember, this is a special question. If I have to see whether the question is correct or not, ideally in its original format the question is incorrect. The question becomes correct only when we say neglecting the small minor segment area, and we are basically talking about the segment RP. It is then only that you can calculate the area of the segment PQ, which is formed by the arc PQ. Okay, moving on to question number 2. Okay, question number 2 basically talks about find the area of the shaded region in 12.2. Okay, so there are two concentric circles with radius. And I am slightly changing the diagram so that it becomes easier for me to understand. As long as you draw the same diagram, whether it was drawn at this angle or you're drawing it at this angle does not make any difference, because at the end of the day, whatever said and done, whichever question has been given to you, you are supposed to understand it in your own way and then solve it, right? So I have not changed the diagram. The only thing is I have just changed the orientation of the diagram. The rest remains the same. If the angle formed by the sector is 40 degrees, I have taken the angle as 45 degrees only. If this is O, this point is B, this point is A, I have taken the same. This is D and this is C. So basically what are they asking you to calculate? They are asking you to calculate this area. Okay. So can I say that in this case it is just like applying the formula of the sector. So the area of the sector. Now which sector am I basically referring to? I am referring to the sector OAC minus the area of the sector. Which sector? OBD is how you get the shaded area of the shaded portion. Once you know this, simply apply the area formula in which pi r square. Now radius are different, so pi will be common. What is going to be common? Other thing that is going to be common is theta upon 360 degrees, which is 40 degrees upon 360 degrees. This is something which is going to be common. And then inside, what will you do is, you will subtract the square of their radiuses. So let's say the outside radius is R1 and the inside radius is R2. This is what you are expected to do. So here what I have assumed here is the outside radius OA is R1 and the inside of the inner circle, the radius here is R2. Okay, now this value is given to you as 7 centimeter and this value is already given to you as 14 centimeter. So all you need to do here is you will say that this is 22 by 7 into 9, 1 by 9 into 14 square minus 7 square, which is just like saying 14 minus 7 into 14 plus 7, applying the formula a square minus b square, which eventually you will say this is 22 by 7 into 1 by 9 into 7 into 21. So which eventually you can say is 154 by 3 centimeter square.